The first question on the take-home portion of the midterm was similar to one that you had worked on in class, and I had kind of told you in class that to expect to have a problem like this for the take-home part of the midterm, and here it was. So most of you didn't have any problems figuring out the equation for the line. You could find the slope and then substitute in a point to find the y-intercept, and here the y-intercept actually was negative. And so you could put in the y-intercept and the slope, and you came up with an equation, f of x equals negative 5 plus 2.5x. And you could plug in some points to check and make sure that that equation seems to work for the points that you know on that line. For the exponential curve through here, instead of finding a slope, we need to find the growth factor, what we're going to multiply by each time to get from 20 up to 70. And actually, since there are 20 times that we would multiply by whatever that growth factor is, be the growth factor to the 20th power would increase from 20 up to 70 in that ratio, so it'd be like 3.5 times. And we can do the 20th root or the 1/20th power of both sides to figure out what that growth factor would be. It ends up being 1.065. And so if you substitute that into the general form, we just need to know that initial value. And that's the initial value when x is 0, not the initial value of 20 when x is 10. So we can, though, substitute in a known point to figure out that initial value when x is 0. So I put x equals 10 and y equals 20, the lower point that's given on the curve. And if we substitute that in and then solve for b, we end up with b, sorry about that, being equal to 10.69. Now we can substitute in the initial value and the growth factor and get an equation for the exponential growth. And we can even check that equation here to make sure that if you put x equal 10 in, that you get y is equal to 20 on this.